Till now we have learned two different types of linked lists, which are single linked list and circular single linked list. So in this video we will start to learn another type of linked list, which is double linked list. Okay, let's recap what's the difference between double linked list and single linked list. In the case of single linked list, each node refers to the next node. As you can see from this sample that node 1 reference to node 2, node 2 reference to node 3, and node 3 reference to node 4. But there is no way that any node can point back to the previous node. So if you want to traverse from node 3 to node 2, that it's not possible in case of single linked list. This is limitation of single linked list, because here the reverse traversal is not possible. To overcome this problem, we have a double linked list. In the double linked list, each node contains two references that references to previous and next node. This allows us to traverse forward and to traverse backward, which means that we can easily come back from node 3 to node 2 and from node 2 to the node 3. So in both ways, traversal is possible. Now let's see how can we create a double linked list. The first thing that we are going to do here, we need to create head and tail references, and then we will create blank node. Then after creating a blank node in memory, we assign a value to this node. Let's say the value of this node is 5. Since it's the only node in the list, the previous and next references will be the null. So then we need to connect head and tail to this node. So we know that the physical address of this node in the memory is 111, so we will set head reference to 111. So by setting this to 111, it creates a link between head and this node over here. Then the next step is we need to create a link between tail and this node. Once again, we will update tail references with the physical location of this node, which is 111. So by updating tail, we are creating connection between tail and this node over here. So if we put all these steps together, we can create an algorithm of double linked list creation. So the algorithm starts from here. It takes node value as a parameter. Then in the next step, we are creating blank node. Then after creating blank node, we are assigning value to this blank node. And this value comes from the parameter over here. Then the next step is we are setting next and previous references of this node to null. So after setting these references to null, we need to create a link between head to this node and tail to this node. So in the next step, we are setting head to this node and tail to this node. Then after doing this step, we terminate our algorithm. So the creation of double linked list is completed. Now let's switch to Visual Studio Code and create double linked list in practice. Okay, now here we will create our node class and double linked list class. I removed the node class that we created before because in case of double linked list, the node class is different. So here, the first thing that I'm going to do, I will create node class. Class node. So inside this class, we have, as always, init function. The self is default parameter here, and it takes value. So by default, value is none. Then we know that in our node, we should have three variables. The first one will be the value of this node. Then self value, we are setting the value to the value that comes from the parameter. Then the next property of our node is next reference. So then we set it to none. Then we should have previous reference for this node. So I will create previous reference over here, and which will be set to none also. So after creating our node class, I will create our double linked list class. Here I will create class doubly linked list. Then inside this class we will have again init function. So by default, self is a parameter. So we know that in our double linked list we should have head and tail. So I will create head here, which will be set none. And the next property is tail, and this will be set to none. So with this, our double linked list and node class is completed. So here inside double linked list class, we will create our methods. But before creating our methods, I want to add an extra method over here, so which makes it easier to print out our double linked list. So by printing out our double linked list, the operations that we will perform on our double linked list can be seen easily. So that's why I put a default method over here, so which helps us to print out our method. So it will be iter like this. Then node starts from the self dot head, and while node yield node, and node equals to node next. So this function helps us to print out our double linked list. Now here under this function I will create the function that we want to create in this lecture, which is creation of double linked list. So I'll comment here creation of double linked list, linked list. Then here I will create our method. So our method will be create double linked list. This method by default takes self as a parameter, and as we said in our algorithm, it takes node value. So the first step in our algorithm is to create a node and assign a value to it. So I will create node over here, and based on the node class that we created. So here I will set the value of node, the value that comes from the parameter. So with this we created our node. So the next step is we need to set next and previous references to node. So node.previous equals to none, and node.next will be none. Then we need to create a connection between head and this node and tail and this node. So we will set self.head equals to node and self.tail node. So after finishing this, I will just return saying that the double linked list is created successfully. So with this, our creation of double linked list method is complete. Now let's see how this is working in practice. So here I will create double linked list based on the double linked list class. Then I will call this create method, which will take the value of 5. So after running this method, let's print out our double linked list. As we said before, we will print out from here. So let's run our code. You see that our double linked list is created with one element, which has the value of 5. So as you see, our method works correctly. Now you might be interested what is the time and space complexity for this method over here. As always, we will start from the first line. So in the first line, we are creating a node and assigning value to it. And this takes O1 time complexity because this is not time consuming operation. Then in the next line, we are setting previous references to none. This is also O1 time complexity. And then we are setting next reference to none. And this is also O1 time complexity. Then setting head and tail to this node also O1 time complexity. At the end, we are just returning default text message over here. This is also O1 time complexity. So if we combine all these complexities over here, we are getting O1 time complexity, which means that creation of double linked list takes O1 time complexity. Now you might be interested what is the space complexity for this method over here. The space complexity is also O1 because in this case, we are just creating one node over here. So it does not take much space in the memory, which means that this is O1 time complexity. So this is all for this lecture. So in this lecture, we have discussed how can we create double linked list, and we have learned an algorithm of creation of double linked list, and we have created it in practice. And we saw what is the time and space complexity for this operation over here. Now in the next lecture, let's learn how can we insert an element in double linked list. See you there. Alright. In the last video, we have learned how to create double linked list. Now in this video, we will look at how to insert a new node to the double linked list. As we had in single linked list, here again we have 3 cases to insert a node into a double linked list. So these cases are inserting a node at the beginning of double linked list, inserting a node at the end of double linked list, and finally inserting a node after any particular node. Okay, let's start inserting a node at the beginning of double linked list. So here, the first step that we are going to do, we will create a blank node in the memory. So after creating a node in the memory, we will assign a value to this node. So in our case, the value of new node is 10. Then we know that we are inserting a node at the beginning of double linked list. So at the beginning of double linked list, the node's previous reference is null. So we will set this node's previous reference to null. So after setting this to null, we need to set next reference of new node. So next reference should point to the first node, so we will update next reference to the physical location of first node. So the physical location of first node in our case is 001, so we will update new node's next reference to 001. So by updating this, we are creating a link between new node and node 1 over here. Then we need to create a reverse link between node 1 and new node. So to do so, we need to update the previous reference of node 1 to the physical location of new node. So in our case, physical location of new node is 002, so we will update the previous reference of node 1 to 002. So by doing this, we are creating reverse link between node 1 and new node. Then finally, we need to create a link between head and this new node, because new node becomes the first node in our double linked list, so the head should point to the new node. So by updating head reference to the physical location of new node, we are creating a link between head and this new node. So after creating this link, the link between head and node 1 will be destroyed. So with this, inserting a node at the beginning of double linked list is complete. Now let's see how can we insert a node at a specified location in double linked list. So let's say we want to insert a node between node 2 and node 3. So here again, the first step is we will create a blank node in the memory. Then after creating this new node in the memory, we will assign a value to it. So in our case, the value of this node is 20. Then the next step is we need to loop through the double linked list until we reach the node which is located before the location that we want to insert this new node. In our case, we want to insert it between node 2 and node 3, which means that we will loop until we reach the node 2. So when we reach the node 2, we know that next reference of node 2 points to the node 3. So we need to create a link between new node and node 3. So in this case, as a first step, so we will update new node's next reference to physical location of node 3. So we see that in node 2, the next reference points to the node 3. So we can take this value over here, update it to our new node's next reference. So by updating this next reference to the physical location of node 3, we are creating a link between new node and node 3. Then the next step is we need to update the previous reference of new node over here. Then we will set this previous reference to the physical location of node 2, and this creates a link between, and this creates a reverse link between new node and node 2. Then the next step is we need to set node 2's next reference to the physical location of new node. So we will update node 2's next reference to the physical location of new node, which is 555, and by doing this, we are creating a link between node 2 and new node. So after creating link between them, the link between node 2 and node 3 get destroyed. Then the last step is we need to create a reverse link from node 3 to new node. So to do so, we need to update previous reference of node 3 to the physical location of new node. So when we update it, a reverse link between node 3 and new node is created. And by doing so, a reverse link between node 3 to node 2 gets destroyed. So with this, we successfully insert a new node in the middle of double linked list. Now let's continue to the next case in which we want to insert a node at the end of double linked list. So here again, the first step is we will create a node and assign a value to it. So in our case, we create a node in the memory which is located in 444 location, and the value of this new node is 20. So here, we know that we are inserting the node at the end of double linked list, which means that the next reference of this node will be null. Then we need to update the previous reference of this node. So the previous reference of this node should point to the last node over here, and we know that last node's physical location in our case is 333. So if we update this previous reference to 333, it will create a reverse link between new node and node 4. Then the next step is we need to update next reference of last node to point this new node over here. So we know that physical location of new node is 444, so we will set next reference of node 4 to 444. So by setting it to 444, we are creating a link between node 4 and new node. So finally, we need to set our tail to reference to our new node. So we know that our new node's physical location is 444, so we will set tail's reference to 444. So by setting it to 444, we create a link between tail and new node. So when we create a link between tail and new node, the previous link between tail and node 4 get destroyed. So with this, we successfully insert an element at the end of double linked list. So this is all for this lecture. So in this lecture, we have learned 3 different cases of inserting a node to double linked list. Now in the next lecture, let's combine these 3 different cases in one algorithm and see how this works. See you there. Alright, in the previous video we have seen how the insertion of a new node into double linked list works in 3 different cases. So in this video we will combine all these 3 cases into one algorithm. And this takes our life easier when we create an insertion method in any programming language. So the algorithm starts with taking 2 parameters. So it takes node value and location as a parameter. Then the next case in our algorithm, we check if the head exists or not. If head does not point any node, then we terminate our algorithm. Otherwise, if head points to any node, then we continue to create a new node and assign a value to this node. Then after assigning value to this new node, we continue to check our location parameter over here. So if location parameter points to first, it means that we want to insert a new node at the beginning of double linked list. So here, we need to perform these operations over here. So we know that the first node's previous reference in double linked list has to be none. So the first stage over here, we set it to none. Then we need to set next reference of new node to the first node. So we know that head stores the first node physical location. So we are setting new node's next reference to head. Then we know that in double linked list, there is a reverse link between each node. So here we need to create reverse link between first node and new node over here. So we know that head stores the first node's physical location. So head.previous will be the previous reference of first node. So by setting this head.previous to new node, we are creating reverse link between node 1 and new node. Then we need to update our head to point to the new node. So here we are setting head to new node. So with this we are creating a link between head and new node. So with these steps over here, new node is inserted at the beginning of double linked list successfully. Then we terminate our algorithm. Then the next step is we are continuing to check our location parameter. If the location parameter points to last, it means that we want to insert an element at the end of double linked list. In this case, we are doing these operations over here. We know that the last element's next reference in the double linked list has to point none. So here we set this new node's next reference to none. Then we need to create a reverse link between this new node and last node. So we know that tail stores the location of last node. So by setting new node's previous node to tail, we are creating a reverse connection between last node and this new node over here. Then we need to create a link between last node and new node. So we are setting tail's next reference, which is the last node's next reference, to new node, and with this we are creating a link between last node and new node. Then we need to point our tail to new node. So we are updating tail to new node, and with this we are creating a link between tail and new node, and a link between tail and the last node gets destroyed. And after doing these steps, we terminate our algorithm. Then we continue to check location parameter one more time. In this case, if location parameter points to any given location in our double linked list, so in this case we need to insert a node at the middle of double linked list. So here we need to traverse through double linked list until we reach the place which is location -1. Then here we are setting the new node's next reference to the current node's next reference. We know that current node's next reference points to the next node in the double linked list. So with this we are creating a link between new node and next node. Then we need to create a reverse link between new node and current node. So we are setting the new node's previous reference to current node. So with this we are creating a reverse link between new node and current node. Then we need to create a reverse link between next node and new nodes. And we know that now new node's next reference is next node. So by setting its previous reference to new node, we are creating a reverse link between next node and new node. Then we need to create a link between current node and new node. By setting the current node's next reference to new node, we can create a link between them. I know that this seems very complicated over here, but when we implement it in our code, in the next lecture, you will see that it becomes very easy. So after completing these steps, we terminate our algorithm. So with this, our insertion algorithm is completed. So here we combine 3 different cases in one algorithm. Now in the next lecture, let's use this algorithm and create insertion method using Python. See you there. Alright, in the previous lecture we have seen So how the algorithm of inserting a node in a double linked list looks like. Now in this lecture we will create an insertion method based on the algorithm that we saw in the previous lecture. So if you have not watched the previous lecture, I advise you go back and watch it, because this makes it easier to create the method over here. So by using the algorithm that we explained in previous lecture, you can create insertion method in double linked list in any programming language very easily. So here we will start to declare our method. So method will be insert node. By default it takes self parameter, and as we mentioned in our algorithm, it takes two parameters over here, which is node value and location. Then as a first step from our algorithm, we need to check head value. So if self.head is none, then we'll print out saying that the node cannot be inserted. Otherwise we will continue to our algorithm. If we have head, then we will create new node based on the node value that comes from this parameter over here, and we will create new node based on the node class that we created in our previous lecture. So here it will be node value. Then after creating a node and assigning value to it, in if condition we will check our location parameter. As we said before, if location equals to 0, it means that we want to insert an element at the beginning of double linked list. So when we insert an element at the beginning of double linked list, the first step over here we set new node's previous reference to none, because the first node's previous reference in double linked list is null. So we set it to none. Then we need to create a link between this new node and first node. So we will set new node's next reference to first node, which is the head. In head we have the first node's physical location. Then we need to create a reverse link between first node and new node. So to do so we need to update the first node's previous reference. So we will do it like this and set it new node. Then we need to change the head reference to point to new node. So I will update head to new node. These are the steps that we explained in our algorithm. So if something is not clear, you can go back and watch it. But as you examine this very carefully, everything will be clear, because here we are just setting the previous reference of new node to none, and then we are setting the next reference of this new node to point to the first node. Then we are creating a reverse link between first node and new node. Then we set our head to this new node. And with this, insertion of an element at the beginning of double linked list is complete. Then we are continuing to the next case, in which we want to insert an element at the end of double linked list. So here, location, if location equals 1, it means that we want to insert an element at the end of double linked list. So in this case, the first step over here, we need to set the next reference of new node to none, because the last node's next reference in double linked list should be none. So next will be none. Then we need to create a reverse link between this new node and last node. So to create a reverse link, we need to update previous reference of this new node to last node. And we know that in tail we have last node's physical location, so we are setting it to tail. Then we need to create a link between last node and new node over here. So to create a link between last node and new node, we need to update last node's next reference. So self-tail.next will be new node. Then finally we need to set tail to reference the new node over here. So self-tail will be new node. So with this, we are inserting an element at the end of double linked list. Basically, as we said, the next reference of last node in double linked list should be null, so we are setting it to null, and we need to create reverse link between this new node and last node in our linked list. Then that's why we are setting previous reference to tail. In tail now we have last node's physical location, that's why we are setting it to tail. Then we are creating a link between last node to new node, and we are doing it like this by using tail next reference. Then we are setting tail to new node, and with this we are creating a link between tail and new node. Then the last case is we want to insert an element at the middle of double linked list. So in this case, we have to loop through double linked list. So to loop through double linked list, I will create temp node over here, which will take the head value, which is the first node in our double linked list. Then I will create another variable, which is index. I will set it 0. Then while index less than location 1, as we said, we need to traverse through double linked list until we reach location -1. Then here in each step we set our temp node to the next node, and we increase index by 1. Then when we reach the location -1, we need to change our references over here. So the first thing that I'm going to do, I need to create a link between new node and the next node. So to create a link between new node and next node, I need to update the next reference of new node. And we know that our current node's next reference is the next node. So our current node now is temp node, and we are setting next. Then we need to create reverse link from new node to the current node. So I need to set new node's previous reference to current node, which is temp node now. And we need to create a reverse link between next node and new node. So to do so, in our case in the next reference of new node we have next node. So we can do it like this: new node dot next dot previous, and we can set it to new node. And this creates a reverse link between next node and new node. Then we need to create a link between current node and new node. So to do so, we know that our current node is temp node, so we need to set next reference to new node. So with this, our algorithm is finished. With this part of code, we are inserting an element at the specified location in double linked list. Let's run our code and see how this is working. One more time, here I have code that we wrote before, in which we are creating double linked list and printing it out. So here, as you see, we are creating using create double linked list method and with the value of 5. Then we are printing out our double linked list over here. Then here, after printing out it, I will call our insertion method to insert node in various places in our double linked list. So the first thing that I'm going to do, I will insert 0 at the beginning. Then I will insert another element at the end. So for example, put 2 at the end. Now one more time I need to print out our double linked list. Now let's run our code and see how this is working. Now you see that we have an error over here in print statement. If we go back, you'll see that I mistakenly put here another sign, so I need to delete this. And here also we have another error, which means that we need to change it to elif, not if. So save and let's rerun our code. I'll clear it and run it. You see that it works perfect. So here we created double linked list with one element, then we inserted 0 at the beginning of double linked list, then we inserted another element at the end of double linked list. Let's try to add an element after these 5 over here. So to do so, I will call our function one more time with the location of 2. So here I'll put, for example, 6 and run our code. You see that 6 is inserted after 5. So all 3 cases are working perfectly. Now let's see what is the time and space complexity for this method over here. So to make our life easier, I'll just close this terminal over here and put it like this to see this method in one window. Now, as always, we will start from the beginning. Here, in the first line of code, we are checking head reference and printing out message over here. And we know that this is of one time complexity because it's not time consuming operation. Then in the else condition, we are creating new node, which is also of one time complexity. Then inside if condition, we are checking location parameter. After checking location parameter, and we are updating the reference of new node and first node and head. And we know that updating references is of one time complexity, which means that the if condition over here takes of one time complexity. Then we continue to the next part of this if condition. Here again, we are checking the location parameter and updating the references. So which means that this part over here also takes of one time complexity. Then we continue to the last part of this if condition over here, which is else part. So in the else part, we are creating a temporary node and a temporary variable. And creating these variables over here also takes one time complexity. But when we reach to this part of code over here, we see that we have loop through double linked list, and we know that looping through any given list is n time complexity. So which means that this part of code, which is looping through a double linked list, is n time complexity. And then updating of previous and next references is O1 time complexity, which means that this part over here takes O1 time complexity. So if we combine all complexities over here, we will get n time complexity, because we know that when we combine complexities, we are eliminating non-dominant terms. So in our case, non-dominant terms are O1 time complexities over here, which means that the total time complexity in the worst case is n. And the space complexity for this operation is O1, because here we are just creating two nodes over here. So the first node, we are creating this one over here, and the other node is we are creating as a temporary node over here. So which means that the space complexity is O1. Now this is all for this lecture. In this lecture, we have created a method which insert a node in 3 different places in our double linked list. And we checked our method and we have learned what is the time and space complexity for this method over here. Now in the next lecture, let's see how can we traverse through double linked list. See you in the next lecture. Hi there. Now in this video, we will look at how to traverse through a double linked list, which means that we visit each node inside a double linked list. Let's say we have a double linked list like this. So steps to traverse through double linked list remains the same as we did in single linked list. So we start from the first node and print its value. Then we move to the next node and print its value, node 2. Then we move to third node and print its value. And then we move the last node and print its value. And that's how traversal works in double linked list. Here we are looping through double linked list until we reach the last node. So how do we know that this is the last node? We know that last node's next reference points to null. So when we reach here, we stop over here. Now the algorithm of double linked list traversal looks like this. So here we start with the checking head. If head does not exist, it means that we don't have any node to traverse, so we terminate our algorithm over here. Otherwise, we continue to loop from head to tail, and in each step we print the value of node until we reach the tail. And that's how the algorithm of traversal in double linked list look like. Now, based on this algorithm, we can create a method. We can create a method in Python which traverses through double linked list. Now here, inside double linked list class, we will create a new function which is called traverse DLL. So I will declare it like this: if traverse DLL, and the self is a default parameter. So apart from self, it does not take any parameter. And the first step over here, we are checking head parameter. So self head is none. We print saying that there is not any element to traverse. Otherwise, we create a temporary node over here, which will take the value of first node. So by assigning head to it, we know that head stores the value of first node. So we are starting from the first node. So inside while loop, we will write something like this: while temp node. So we will print out the value of temp node. Then each step we are setting it to the next node. So temp node equals temp dot next. So with this, our traversal function is complete. So this is how our traversal function looks like in double linked list. So let's see how this is working in practice. We have a code over here from previous lecture, which is creating double linked list and inserting some elements to it. So here I will call our traversal function to see how this is working. So after printing out this double linked list, I will just call traversal function and to see if it is working correct or not. So let's run our code. So when we run our code, we see that this is our double linked list over here. So by traversing through it, we are visiting each element of this double linked list over here. As you see, first we print out with the value of first node, which is 0, then the value of second node, which is 5, then the value of third node, which is 6, and then the value of fourth node, which is 2. As you see, our traversal function works correctly. Now you might be interested what is the time and space complexity for this method over here. So once again, we will start from the first line of method. So it's obvious that if condition, which is checking the head reference, takes O1 time complexity, then in the else condition we are creating temporary node, which takes also O1 time complexity. Now when it comes to the while loop over here, it takes On time complexity, because here we are visiting each and every element of double linked list and printing its value, which means that it will take On time complexity. So if we combine all these time complexities over here, we get On time complexity. So traversal of double linked list takes On time complexity. And the space complexity for this method is O1, because here we are just creating one temporary node over here. So that's why the space complexity is O1. An additional space is not required in the memory to perform this operation over here. Now this is all for this lecture. So in this lecture we have learned how can we traverse through double linked list. Now in the next lecture we will look at reverse traversal in double linked list, because we know that in double linked list we can always come back from the next element to the previous one. So see you there. Alright, in the last video we have seen how to traverse a double linked list. Now here we will look at how to reverse traverse. We know that in double linked list there is a backward connection between nodes. So this means that we can traverse backwards through node. What we are doing here is we start traverse from the last node until we reach the first, and in each step we print the values of node. In our case we start from node 4 and print its value, which is the 4. Then we traverse to the node 3 and print its value. In our case it's 3. Then we traverse to node 2 and print its value, which is 2, and then we traverse to node 1 and print its value, which is 1. When we reach to node 1 we terminate our traverse. So how can we know that we reached the node 1? We know that the previous reference of node 1 is null, so when we reach over here we terminate our algorithm. Now let's look at how the algorithm of this traversal looks like. Here we start again by checking head value. So if head is null we terminate our algorithm over here because there is no element to traverse. But if head points to any given point, then we start to loop through double linked list. Here we start from tail to head, and in each step we are printing the value of node over here. Now by using this algorithm over here, let's create our reverse traversal function in Python. So let's switch to Visual Studio Code and create our method over there. So here again we will create our method in double linked list class. So after traversal method we will create another method over here which is called reverse traversal. So here I will declare our method reverse traversal DLL, which means that double linked list. Then this method also takes self parameter as default, and then as a first step we will check head value. So if self.head is none, so here again we are printing message saying that there is not any element to traverse. Else we create again temporary node over here, but this time we assign the value of tail to it, not head, tail, because we will start from the tail to loop. So while temp node, so we print the value of this node, temp node value. Then each step we are setting the temp node the previous value of temp node, because here we are reverse traversing. If we traverse normally we are setting the next value, but if we traverse backward we set previous value. Let's save our function and run it and see how this is working. So here again we have a code over here which creates double linked list and inserts some values to it. As you see here we have traversal. As you see here we called traversal function from our previous lesson. So after this function I will call reverse traversal to see the difference between them. So let's run our code. So as you see that first we are printing out our double linked list, then we start traversing it. The value of first node is 0, then 5, 6, 2. Then when we reach here, our traversal is finished. Then here our backward traversal started. So as you see, it starts from 2650. So to see it very obviously, I can just comment out this function over here and rerun our code. You see that this is our double linked list, and we are traversing from the last element, which is 2, then 6, then 5, then 0. So our traversal function works correctly. Now let's see what is the time and space complexity for this method over here. So here again we start from the first line of code. So we know that checking if value and printing a message is O1 time complexity. Then in the else condition we are creating a temporary node which takes the tail value. This is also O1 time complexity. Now here while loop takes On time complexity. So if we combine these complexities over here, this one also takes On time complexity. So the time complexity for reverse traversal also is On. Now the space complexity obviously is O1 because here we are just creating one node over here as a temporary node. Now this is all for this lecture. So in this lecture we have learned how can we reverse traversal through double linked list, and we learn time and space complexity of this method over here. Now in the next lecture let's look at how can we find an element in double linked list. So see you in the next lecture. Alright, in the previous videos we have seen how to traverse and reverse traverse through a double linked list. Now in this video we will look at how to search a given value in double linked list. The steps for searching a value inside double linked list is the same as with the single linked list. Let's say we have a double linked list like this, and we want to see if there is a value equals to 4 or not. So as we did in traversal of double linked list, we start from the first node inside the loop. Instead of printing the value of node, we compare it with the search value. So in our case we start from this node over here, and we are comparing it with the value of 4. So we see that the first node's value is not 4, so we are traversing to the next node. Now here in the second node we are doing the same operation. We are checking the value of second node, and we are comparing this value with the value that we are looking for. So in our case we are looking for value of 4, so this is not equal to 4, so we will traverse to node 3. So here again we compare the value of this node with the value that we are looking for, and we see that it's not the value that we are looking for, and we are traversing to the next node. Now in this case we see that 4 is located in the node 4, so which means that we stop our loop over here and print the value of 4 from here. But when we reach the last node and we see that the value is not exist, so we return message saying that the value does not exist in the double linked list. Now the algorithm of search in double linked list looks like this. Our algorithm starts with the node value. Node value comes to our algorithm as a parameter. Then as a first step, here again we are checking head. If head points to the null, it means that we don't have any element to traverse and we cannot find our element. We are terminating our algorithm and saying that there is no element for searching. If head points to any given node, then we are looping through double linked list. In each step we are checking the value with the parameter value that we are receiving here. In each step we are checking the current node's value with the value of parameter that we are receiving here. So if the value of node equals to value that comes from the parameter, then we terminate our algorithm over here. Otherwise we loop double linked list until we reach the end of double linked list. Now based on this algorithm, let's switch to Visual Studio Code and create search method in Python. Now here again inside double linked list class we will create another method which is called search method. So I'll declare our method like this, search DLL, which takes self as a default parameter, and it will take node value. This is the value that we are looking for inside our double linked list. Now here as a first step we will check head value. If self.head is none, then we will return saying that there is not any element in the list. Otherwise, first we will create temporary node over here which takes first node's value. So in this case it will be head. Then we start to loop from first node until we find the node that we are looking for. So here inside while loop we are writing if condition like this. So if temp node dot value equals the value that we are looking for from this parameter, we are returning the value of node. Otherwise we are setting temp node to next node. So when the loop finished and we cannot find our element, we are returning saying that the node does not exist in this list. So with this, our search function is completed. Now let's see how this is working in practice. So one more time, here we have a code which is creating double linked list and inserting elements to it. So here I will call our search function to search, for example, for value of 6. We know that value of 6 exists in our double linked list, so it will return the value of 6 over here. So let's run our code. You see that the value is not printed out here because we have not printed out our output over here. So if we just print out and run our code one more time, you see that the value of 6 is printed out over here. So which means that the node with the value of 6 exists in our double linked list. If I run this search function, for example, for value of 7, you will see that it does not exist in our double linked list. So it says that the node does not exist in this list, which means that our search function works correctly. Now let's look at what is the time and space complexity for this method over here. We know that checking head value and returning a message is O1 time complexity, so this part over here will take O1 time complexity. Then we continue to the else part. In the else part we are creating temporal node. So creating a temporal node is O1 time complexity also. Then we come to the while loop over here. So the while loop takes On time complexity. Now the inside while loop we have if condition over here, which takes O1 time complexity. And finally, so the last part, setting the temp node to the next node, takes O1 time complexity also. So if we combine these complexities over here, we get On time complexity. So the time complexity for searching in a double linked list is On. Now the space complexity is O1 because it can be easily seen that we are just creating a temporal node over here. So which means that it takes O1 space complexity. Now this is all for this lecture. In this lecture we have learned how can we search in a double linked list, and we have learned what is the time and space complexity for this method over here. See you in the next lecture. Alright, in the last lecture we have learned how can we search for a node in double linked list. Now in this lecture we will look at how to delete a node in a double linked list. The process of deleting a node from double linked list is similar to single linked list, but there are small differences that we are going to talk about in this lecture. As in single linked list, here also we have 3 cases of deleting a node from a double linked list, which are deleting first node, deleting the last node, and delete any given node in the middle of double linked list apart from first and last node. Firstly, we will look at how to delete the first node of double linked list. The first thing that we are going to do here is if this node is the only node in our double linked list. So if this is the only node in our double linked list, in this case steps are very simple. We just need to update the head reference to null and tail reference to null, because here node 1 is referenced only by head and tail. So if we set head reference to null, the link between head and node 1 is broken. So node 1 is not referenced by head anymore. So the next step here is we just need to set tail reference to null. So if we set tail reference to null, the link between tail and node 1 is broken. So node 1 is not referenced by tail. So in this case we see that there is no any reference to node 1, so node 1 is available for garbage collection. So the system automatically deletes node 1 from the memory. So with this, the case 1 is completed. So by setting head and tail references to null, we can delete a node from double linked list in which we have only one node. Let's continue to the second case in which we have more than one node in double linked list. Let's say our double linked list is like this. Here we have more than one node and we want to delete node 1 over here. So how do we do it? Here all we have to do is to update head reference to point node 2. If we update head reference with the next reference of node 1, this will create a link between head and node 2. So if I set head to 111, which is physical location of node 2, this creates a link between head and node 2. And by doing this, we delete the link between head and node 1. Now node 1 is not eligible for garbage collection because there is a reverse link from node 2 to node 1. So node 1 is pointed by node 2. So we need to delete this link over here. So how can we delete this link over here? So we know that the first node's previous reference in double linked list. So if we set node 2's previous reference to null, this will delete a reverse link between node 2 and node 1. So if I set it to null, you see that the link between node 2 and node 1 is deleted. Now node 1 is not referenced by any node, So this is eligible for garbage collection. The garbage collector can come and delete this node from the memory. So with this, deletion of a node from beginning of double linked list is complete. Now let's see how can we delete the node from the middle of double linked list. Let's say we want to delete node 3 from this double linked list. So here we need to find the node before this node, and we need to create a link between this node over here and with this node over here. So how do we do this? So to find the node which is before node 3, we need to traverse from node 1 until we find the node before node 3. So if we traverse from node 1 to node 2, we see that node 2 is the node that is located before node 3. So here we stop and we need to create a link between node 2 and node 4. So first we update node 2's next value with node 3's next value, which points to node 4. So here node 3's next value is 333. So we need to update node 2's next value to 333. So if we update it, it creates a link between node 2 and node 4. And by doing this, the link between node 2 and node 3 gets deleted. Then we need to create a reverse link from node 4 to node 2. So we update previous value of node 4 to the physical location of node 2. So we know that physical location of node 2 is 111. If we set previous reference of node 4 to 111, it will create reverse link between node 4 and node 2. So by doing this, a reverse link between node 4 and node 3 gets deleted. Now node 3 is not pointed by any node anymore, so this is eligible for garbage collection, so the garbage collector can come and delete this node from here. So node 3 gets deleted. So here we have learned how can we delete any given node from middle of double linked list. Now let's continue to the next case in which we will delete a node from the end of double linked list. So here again we have two cases. The first case is in which we have only one node in our double linked list. So it's similar the way that we deleted when we delete first node from double linked list. So here we are setting the head reference to null. So by setting this, the link between head and node 1 gets deleted. Then the next step is we set tail reference to null. And by setting tail reference to null, the link between tail and node 1 is deleted. So node 1 becomes eligible for garbage collection. So the garbage collector can come and delete this node from here. So node 1 is deleted. Now the next case is we have more than one node in our double linked list. So in this case, if you want to delete node 4 from here, so this is the last node, the first step that we are going to do, we need to change the tail reference to point to the node that is before the last node. So in this case, if we set tail reference to the tail previous value, we can create a link between tail and the node that is before the last node. So we know that right now tail points to the last node, which is located in physical location of double 3. So previous reference of this node over here points to the node that is before the last node. So if I set tail to tail previous, it will create a link between tail and the node that is located before last node. So by doing this, a link between tail and the last node gets deleted. Then now we know that tail points to the node 3 over here. If we set tail's next reference to null, we will change this value over here to null, and this will delete a link between node 3 and node 4. So the link between node 3 and node 4 gets deleted. Now as you see, there is no any node that points to the node 4 over here, which means that node 4 is eligible for garbage collection. So the garbage collector can come and destroy this. So with this we can delete a node from the end of double linked list. So the last node gets deleted. Now this is all for this lecture. So in this lecture, we have looked at deletion of a node from a double linked list in 3 different cases. So we have learned how can we delete a node from beginning of double linked list, delete a node from any given location in double linked list, and we learn how can we delete the last node in double linked list. Now in the next lecture, let's combine these 3 cases and create an algorithm of deleting a node in double linked list. So see you in the next lecture. Alright, in the last video we have seen how to delete a node from double linked list in 3 different cases. Now in this video we will combine all these 3 different cases in one method. So let's get started. So our algorithm starts with the parameter of location. So it takes one parameter, which is location. Then we continue to the first step in which we are checking head value. So if head equals to none, it means that we don't have any element in our double linked list, so we terminate our algorithm. Otherwise, we continue to check location parameter. So if location parameter points to first, it means that we want to delete a node at the beginning of double linked list. So here we have 2 different cases. The first case is in which we have only one node in our double linked list. So in this case, we are setting head and tail references to none over here. Now the second case is if we have more than one node in our double linked list. So in this case, the first step is we need to create a link between head and the second node. We are doing it by setting head to head next, and we need to set second node's previous reference to null. So by setting head to head next, we are creating a link between head and second node. So after doing this, so our head over here stores second node's physical location, so we can set head previous to null, which will change the second node's previous reference to null. So with this, we complete our deleting of a node from beginning of double linked list. So we terminate our algorithm. Now the second case is location parameter if the location points to last node. So if this points to last node, it means that we want to delete a node from the end of double linked list. So here again we have two cases. The first case is if we have only one node in our double linked list, so we are just setting the head and tail references to null, and this deletes the link between head and node 1 and tail and node 1. So node 1 becomes eligible for garbage collection, so it gets deleted by garbage collector. Then the next case is if we have more than one node in our double linked list. So in this case, we need to create a link between tail and the node that is located before last node, and then we need to set this node's next reference to null. So by setting tail to tail previous and tail next to null, we are doing this operation over here. So after doing this, the deletion of a node from the end of double linked list is complete. So we terminate our algorithm over here. Now the last case is we want to delete a node from any given location in the double linked list. So here we need to traverse through double linked list until we reach the location that is before the node that we want to delete. So when we reach this location, we need to create a link between current node and the node after the next node. And we need to create a reverse link between the node which is located after the next node with the current node. To do so, we need to set current node's next reference to the current node's next reference, which is the node located after the next node. So then we need to create a reverse link between these nodes. So if we set current node's next reference and previous value to current node, it creates a reverse link between the node which is located after the next node and current node. So after doing this step, so we delete the node which is located at any given location in our double linked list. So with this, we complete our algorithm over here. So this is all for this lecture. Here we have combined three different cases of deletion of a node in double linked list. So by using this algorithm, we can create a method in any given programming language easily, because here we showed these three different cases step by step. Now in the next lecture, let's use this algorithm and create a deletion method in Python programming language for double linked list. So see you in the next lecture. So in this video, we will create a deletion method based on the algorithm that we created in our previous lecture. And we will learn what is the time and space complexity for this algorithm over here. So if you haven't watched our previous lecture, I advise you to go back and watch this lecture, because it makes our life easier to create a deletion method over here. And we will use that algorithm over here to create a deletion method in double linked list. So let's get started. So inside our double linked list class, after the search DLL method, we will create another method which is called delete node. So as always, it takes self as a parameter. And as we said in our algorithm, it takes another parameter which is location parameter. So here, the first step is that we need to check head value. So if self.head is none, it means that we don't have any element in our double linked list. So saying that there is not any element in double linked list. Otherwise, we can continue to our next steps. So in the next step, we are checking our location parameter. So if location parameter equals 0, it means that we want to delete a node from the beginning of double linked list. So here we have two cases. So that's why I will write another if condition over here. So the first case is if this is the only node in our double linked list. So how can we check this? So we know that if this is the only node in our double linked list, so tail and head references point to this same node. So if self.head equals self.tail, it means that we have only one node in our double linked list. So here the steps is we set head and tail references to none. So by setting these references to none, we are deleting a link between head and node 1 and tail and node 1. So after doing this, node 1 becomes eligible for garbage collection. So the garbage collector comes and deletes these nodes over here. Now the next case is if we have more than one node in our double linked list. So in this case, we need to create a reference between head and second node, and we need to set second node's previous reference to null. So how can we do this? So we know that head stores the first node's location. So if we access the head next node, we are accessing the node 2 in our double linked list. So I will set head to head.next, and then after setting this, now our head stores the second node's location. So I can set head.previous to none. So with this, we complete deletion of a node from the beginning of double linked list. Now let's continue to the other case in which we want to delete the node from the end of double linked list. So here we are checking again location parameter. If location parameter equals 1, it means that we want to delete last node in our double linked list. So according to our algorithm, we have also two cases over here. The first case is if we have only one node in our double linked list. So it is similar with the deletion of a node from the beginning of double linked list. So that's why I will copy just this part over here and paste it here. It is the same. Now in else condition, we have another case in which we have more than one node in our double linked list. So if we have more than one node in our double linked list, how can we delete the last node in our double linked list? So here we just need to create a link between tail and the node which is located before the last node, and we need to delete the link between last node and the node which is located before the last node. So how can we do this? So if we set self tail to self tail's previous value, we create a link between tail and the node which is located before the last node, because we know that previous reference of last node points to the node which is located before the last node. Now the second condition is if there is more than one node in our double linked list. If this is not the only node in our double linked list, how can we delete a node from the end of double linked list? So in this case, we need to create a link between tail and the node which is located before the last node, and we need to set the next reference of the node which is located before the last node to null. So how can we do this? So if we set our tail to self tail dot previous, in this case, we are creating a link between tail and the node which is located before the last node, because we know that last node's previous reference points to the node which is located before the last node. So by setting it to tail, we are creating a link between tail and this node, and the link between tail and the last node gets deleted. Now the next case is we need to set this node's next reference to null. So if we set tail.next to none, we delete a link between the node which is located from the last node and the last node. So by updating these two references over here, we are deleting the last node in which we have more than one node in our double linked list. Now the third case is we need to delete a node from any given location in our double linked list. So here in else condition, I will write that case. So here we need to loop until we reach the node that is located before the node that we want to delete. Then we need to update the references. So here I will create current node and set it to self head, which is the first node. Then I will create another variable over here which is index and set it to 0. Then inside while loop, while index less than location -1, we need to traverse until we reach the location -1. We set current node to current node's next reference, because we are traversing to the next node each time. Then we are increasing index variable over here by 1. By doing this, we are reaching the node which is located before the node that we want to delete. So when we reach this part, we need to create a link between current node and the node which is located after the next node. Then the next step is we need to create a reverse link between these nodes. So to create a link between current node and the node which is located after the next node, we need to set current node's next reference to current node.next. And this gives us the location of the node which is located after the next node. Then we need to create a reverse link between these nodes. So if I set current.next.previous to current node, it creates a reverse link between these nodes. So after doing this, we can print out saying that the node has been successfully deleted. So with this, we completed our deletion method. Now let's see how this is working in practice. As always, we have a code over here which is creating a double linked list and insert some values in it.
So here, first after insertion we are printing our double linked list, then we will delete by calling our delete node function, then we will once again print out this double linked list to see the difference. So the first case is we need to delete a node from the beginning of double linked list. So if I run our code, you see that initially our double linked list is like this, then we are deleting the first node. The first node is 0, so it gets deleted. So after deleting it, it shows a message the node has been successfully deleted, and we see that the first node is missing in our double linked list after deletion. So let's delete the last node. If we know that if we put parameter 1, it deletes last node. Let's run our code. You see that the last node is 2 and it gets deleted. So if we want to delete, for example, third node, we will put 2 over here and run our code. You see that 6 gets deleted. Now you might be interested, how can we delete the second node over here? Because when we put 1, it deletes the last node. When we put 0, it deletes the first node. And when we put 2, it deletes the third node. But second node still here. So if we want to delete second node, how can we delete it? So if we call our delete method with any given minus value, it will delete the second node. You see that the second node is missing now. So let's see what is the time and space complexity for this method over here. So to make our life easier, I will just close this terminal over here so that we can see our function in one window. So as always, we'll start from the first line of code in the method. So the first line of code is we are checking head value. And we know that checking head and printing some message over here is O1 time complexity. So this part over here takes O1 time complexity. Then we continue to the else part. In the else part, we have another if condition over here. So the if condition checks location parameter, and inside this if condition, we have another if condition. As you see, here we are just updating the references, any given reference or to null. So we know that updating any given variable takes O1 time complexity. So this part over here takes O1 time complexity. So the same logic applicable over here, and this part also takes O1 time complexity. Now we continue to the next part of this if condition over here. So we see that the operations over here is somehow similar to over here. So which means that both part of this if condition over here takes O1 time complexity. So we don't have any problem over here. Then we continue to the last part of this if condition over here, in which we are creating temporal node and assigning head value to it. And we are creating another variable over here and assigning 0 to it. These assignments over here takes O1 time complexity. Now if we continue to the next line, we see that we have loop over here. And we know that looping any given double linked list is O(n) time complexity. So the loop over here takes O(n) time complexity. Then the last part over here, we are just updating the references of current node, which takes O(1) time complexity, and the breathe statement also takes O(1) time complexity. Now if we combine all these complexities over here, we are eliminating O(1) time complexities because they are non-dominant terms. So the time complexity for deleting a node in the worst case is O(n). Now you might be interested, what is the space complexity for this operation over here? The space complexity is O(1) because here we are just creating a temporal node over here and temporal variable over here, which means that an additional space is not required in the memory to perform this operation. So the space complexity is O(1). So with this, we have completed this lecture. So in this lecture, we have created delete node method for double linked list in which we combined all three cases. Now in the next lecture, let's look at how can we delete entire double linked list. So see you in the next lecture. Alright, in the previous lecture we have created deletion method using programming language and learned the time and space complexity of deleting a node from double linked list. Now in this video, we will look at how to delete entire double linked list and we will implement it in practice. We know from previous lectures that in the case of single linked list, if we set head and tail values to null, then the entire list gets deleted. But here, in the case of double linked list, this is not the case. Because even if we set head and tail references to null, node 1 will not be deleted because node 1 is referenced by node 2 and node 2 is referenced by node 3 over here. So there's a link to these nodes over here. So how can we delete entire double linked list? So in this case, the first step is we will start loop through these nodes and update their previous references. So here we know that first node's previous reference is null, so we are not updating it. Then we are continuing to the node 2, and here when we reach the node 2, we are updating the previous reference of node 2 to null. So by updating this, we delete the reverse link between node 2 and node 1. Then we are continuing to the node 3. Here again we are updating the previous reference of node 3 over here. So by updating this, the reverse link between node 3 and node 4 gets deleted. Then we are continuing to the node 4. Here again we are updating the previous reference of node 4 to null, and this deletes the reverse link between node 4 and node 3. So after completing this step over here, now we can set our head to null. So by setting our head to null, we are deleting a link between head and node 1. Now the last step is we need to set tail reference to null. So if we set tail reference to null, the link between tail and last node gets deleted. So now our first node is eligible for garbage collection. So the garbage collector will come and delete this node over here. So by deleting this node over here, the point from first node to the node 2 gets deleted. So then node 2 becomes eligible for garbage collection. So garbage collector comes and delete this node over here because there is no link to this node anymore. So after deleting this, now we see that there is no link which points to the node 3 over here. So node 3 becomes eligible for garbage collection. So this time garbage collection deletes node 3. Then we see that there is no link to the last node over here. So last node becomes eligible for garbage collection. So garbage collection comes and destroys this. Now with this, deleting of entire double linked list is complete. So now let's switch to Visual Studio Code and create delete double linked list method over there. So here inside double linked list class, after delete node method, we will create another method which is called delete double linked list. So here delete DLL. So as always, by default it takes self parameter. So the first condition in our method will be we check head reference. If self.head is none, it means that we don't have any element in the double linked list. So I'll print out here there is not any node in double linked list. Else, as we said in our as you mentioned, we will start to loop through double linked list. So I will create a temp node over here which will store the value of head. So this is because our loop will start from the head. So while temp node, we set temp node's previous reference to none. So this deletes the reverse link between nodes. And then temp node to temp node dot next, because in each step we are traversing to the next node. Then after updating previous references of nodes to none, then we need to set head and tail references to none as well. So first I will set head none, then I will set tail to none. Then after setting this, I'll print out saying that the double linked list has been successfully deleted. The DLL has been successfully deleted. So let's run our method and see how this is working. So as always, we have created our double linked list and inserted some elements in it. So here, after this print statement over here, I'll call this function delete DLL function, which deletes the double linked list. So let's run our code. You see that initially our double linked list is like this. So we have elements in it. Then after running our method, it shows the message DLL has been successfully deleted. Now here you see that we don't have any element in this double linked list. So our method successfully deleted the elements of double linked list. Now let's see what's the time and space complexity for this method over here. So as always, we will start from the first line of code. So here we are checking head and printing message. We know that this is O1 time complexity. Then we are continuing to the else condition over here. In the else condition, we are creating temporary node and assigning head value to it. This is also O1 time complexity. Then we see that we have loop over here. Looping through all elements of double linked list is ON time complexity. So this part over here takes ON time complexity. Now at the end, we are setting head and tail references to none and printing message over here. These 3 lines of code takes O1 time complexity. Now, if we combine all these complexities over here, we see that our method takes ON time complexity because we are eliminating non-dominant terms, which are O1 time complexities. So the time complexity for this method is ON. And it's obvious that the space complexity is O1 because here we are just creating temporal node over here. So an additional space is not required to perform this operation. Now with this, we have concluded our delete entire double linked list method, and we have learned what is the time and space complexity of this method over here. Now in the next lecture, let's combine all time and space complexities of double linked list together and see what they look like. See you in the next lecture. Alright, till now we have seen different operations on double linked list, and we have learned their time and space complexities. Now in this video, let's put all of them together to see the entire picture of time and space complexity for double linked list. So let's get started. So the first operation over here is creation of double linked list. So the creation of double linked list takes O1 time complexity, because as you know, we are just creating a node over here and setting previous and next references of this node to null and creating a link between head and this node and tail this node, and this takes O1 time complexity. And the space complexity for this operation is O1 because here we are just creating one node. So here an additional memory is not required for this operation. Now the next operation over here is insertion. So insertion takes On time complexity in the worst case, because here we have three cases. So to insert an element at the beginning of double linked list takes O1 time complexity, because here we are just updating the references, but inserting an element at the middle of double linked list takes On time complexity, because here we need to loop to find the location to insert an element in the double linked list. And inserting an element at the end of double linked list takes O1 time complexity. So as we see, in the worst case, insertion takes On time complexity, which is inserting an element at the middle of double linked list. So that's why the time complexity is On. Now the space complexity is O1 because here again we are just inserting one element, so it takes O1 space complexity. Now the next operation over here is searching operation. The searching operation in double linked list is linear search, so we know that linear search takes On time complexity because here again we need to traverse through all elements of double linked list and check for the value that we are looking for. So the time complexity for this operation is On. And the space complexity here O1 because here we are just creating a temporary node and assigning head value to it. So this takes O1 space complexity. Now the next operation is traversing. We know that we can traverse through double linked list forward and backward. Both this operation takes On time complexity because in this case we are visiting each and every node of double linked list and printing their value. In the first case we are starting from head to tail, and in the second case in which we are traversing backward, we are starting from tail to head. In both cases we are visiting each and every element of double linked list and printing their value. This means that this operation is On time complexity. Now the space complexity is O1 because here an additional memory is not required to perform traversing. Now the next operation is deleting a node from double linked list. So we know that we can delete a node in three different places in double linked list. So deleting a node from the beginning of double linked list takes O1 time complexity, but deleting a node from the middle of double linked list takes On time complexity because here we have to traverse through the elements to find the element that we want to delete. So that's why in the worst case deletion of node from double linked list takes On time complexity, but deleting of a node from the end of double linked list takes O1 time complexity. So if we combine these three cases, in the worst case we get On time complexity. Now the space complexity obviously is O1 because here we are just deleting one element from double linked list. Now the last operation is deletion of entire double linked list. So in this case it takes On time complexity because in this case we have to update previous reference of all nodes. So to do so we need to traverse through all nodes and update their previous references, and this is very time consuming operation. That's why it takes On time complexity. Now in this case also space complexity is O1 because here we are just deleting all elements of double linked list. Now with this lecture we have completed another type of linked list, which is double linked list. So here we have completed various operations on double linked list. Now in the next lecture let's look at another type of linked list, which is circular double linked list. See you there.